Hi there, it's Mrs. Tellas. We're going to go ahead and do the notes for 6.3, which is evaluating, identifying, and graphing exponential functions. So this is a 2-day lesson, but we're going to go ahead and put it in a quick 10-minute video. So I'm not going to do all of these. We'll just do a few of them. So what we know about an exponential function is, first of all, it's nonlinear. And second of all, it's in the form of, this is the parent function, y equals ab to the x. Notice that that x is the exponent, which is why it makes it exponential. Okay, so x is the exponent. If the x is in the exponent, it's exponential. It's going to graph a curve when we graph it. All right, so let's decide if these tables are exponential or linear. So when we look at a table to decide if it's linear, we see if it has a slope, a constant slope. We kind of do the same thing for exponential, and we look for a multiplication pattern. So right here, it looks like it's going up by 2. It looks like I'm adding 2 each time. So plus 2, and plus 2. Up here is plus 1. So this has a slope of 2 over 1. So this is linear. Okay, so if I, come across this later in life and I can't remember how to do the table, I would just graph it. So 0, 2, 1, 4, 2, 6, and 3, 8, and it would make a straight line, and then you would know, oh yeah, that's linear. Okay, let's look at number 3. Number 2 is the same as number 1. So as I look at this, I notice that it's going up, and I notice that's not very even. So up here, it's plus 0.75, plus 3, plus 12. Okay, none of that is constant because the top is all plus 1. So I'm thinking maybe not linear, maybe exponential. So I look for a multiplication pattern. Well, I know 1 times 4 is multiplied by 4, and 4 times 16 is multiplied by 4. And I know there's 4 quarters in a dollar, so that's multiplied by 4. And that must be 4 too. This is exponential. Okay, and I know it's exponential because it has a multiply pattern on the y of multiply by 4. All right, so I've done one of each. Now you press pause and try both of those. One of them's linear, one of them's exponential. See if you can figure out which one's which. So this one is obviously multiply by 4. So this one's exponential. Notice that when it's exponential, it's still adding 1 in the x. Okay, the adding 1, the multiply part only applies to the y. And then down here, there's a nice plus 2 going on here. And a nice plus 2 going on here. This has a slope of 1. So this is linear. And again, if I didn't know how to do it, I could graph it and it would make a straight line and I would know it was linear. All right, so on these, this is the second part of your homework. You are just plugging in x into the exponential function. So you're taking this x right here, this 2, and you're taking the x out and putting the 2 in, and then you're evaluating. Feel free to use your calculator, but you also need to show your steps here. So your answer is 9 for that one. So this is y equals negative 4 times 5 raised to the second. So y equals negative 4 times 25. So y is negative 100. Okay, and then let's take a look at this one. So y equals 1/3 times 6 times 3. 6 to the third is 216. And 1/3 of 216 would be 72. So y is 72 there. All right. All right, the last piece of 6.3 is to graph. So you're going to be graphing on big ideas. So graph f of x, remember that's the same as y, equals 4 times 2 raised to the x. Describe the domain and the range. So what we're going to do when we graph is we're going to make a 4-point table with reasonable outputs that fit on the graph. Okay, so I can't pick something that won't fit. So I kind of have to play with it. It's not like consistent, like on lines we do 0, 1, and 2. We're not going to always do 0, 1, and 2. So let's make a quick table. And we're going to evaluate, let's just start with 0. So if we put 0 in there for x, this would be 4 times 2 to the 0. Well, 2 to the 0 is 1, times 4 is 4. So 0, 4 is my first point that I have. That's reasonable. That fits on the graph. Let's try 1. Okay, so 4 times 1, no, 4 times 2 to the 1. So 2 to the 1 is 2, times 4 is 8. So that fits nicely on the graph. Okay, if I do 2, that's going to put me at 16, which is way off the graph. So I don't want to do that. So how about we do -1? So 4 to the 2 to the -1. Well, remember that he's unhappy. Remember from 6.1? So we're going to move that to the bottom. And 2 to the first power is 2. So -1 would be a y value of 2. So -1, 2. Okay, let's do one more. How about -2? Because -1 worked well. So 4 times 2 to the -2. So again, we've got an unhappy. So we move that to the bottom. So 4 over 4 equals 1. So -2, 1. So you can see that it's a curve. So this is what my exponential function looks like. So it will forever be approaching x, but it will never get there. It will never get to that x axis. So this is what my graph looks like. So if we talk about the domain, remember that's the x, and we talk about the range, remember that's the y. So the domain is going to be all real numbers because it's always going to keep growing to the right and it's always going to keep growing to the left. So all real numbers. And then my range is not all real numbers because it's going to always approach 0, but it's never going to get there. It's just going to get closer and closer and closer, but it will never get there. So my range is y is greater than 0. So it's everything above 0. It doesn't equal 0 because it will never get there. There's no number I can put in for x that will make it 0. All right, let's try another one. All right, so I've got -1/2 to the x power. So again, there's no great number here that I'm going to use, but I know I want it to fit on the graph. So if I make my table, I think I'll start with 0. I usually do start with 0. 0 usually is a decent answer. So let's see, we have -1/2 to the 0. Well, anything to the 0 is 1. So this is -1 as my answer. So 0, -1. And if I try 1, so -1/2 to the 1. Well, 1/2 to the 1 is 1/2. And then that'd be -1/2. Well, I can graph that. So 1 and then down a little bit. If I do 2, it's going to give me a fraction that's between here. So I don't think I'm going to do 2. I think I'm going to go the other way and do -1. Okay, so since this is unhappy, I could move the whole thing to the bottom, but then I'd have a complex fraction. So what I think I'll do is go ahead and distribute. So that would be 1 to the -1 and 2 to the -1. Well, they're both unhappy, so I'm switching them. And they're both to the first power. So that ends up being negative on the outside and 2 on the inside, so -2. So when we put in -1, we got -2. So -1, -2. Okay, and you can see the curve, the bend. All right, and then let's go ahead and do 2 just so you can see. So 2, if I put 2 in there, -1/2 raised to the second. So that would be -1 to the second and 2 to the second. So that's -1/4. Now I can graph that. So 2 to the -1/4. So it's right there. If I would have gone with -2, it would have been down here somewhere. Okay, a little bit down here. But you can see that we're going to grow this way and it's going to approach the x. It's never going to reach the x, but it's going to keep getting closer, inching closer and closer up until actually forever. It will never get there. So this is what my point is going to look like, or my line. And it does have arrows in both directions because it keeps growing to the right and to the left, but that makes the domain all real numbers. And this time, and especially because it's got a negative here, the range is below the 0. It's going to keep approaching 0 but never get there. So this is y is less than 0 as my range. We're going to do one more graph and then we're going to be done. All right, so this is a tricky one because it's x minus 3 up here. So we're going to have to play with it to get it to give us numbers that will fit on the graph. So we could try 0. Let's try 0. I always start there, and if it doesn't work, I nix it. So 4 times 2 to the 0 minus 3, and then plus 2. So this here is obviously negative 3, and then that part's unhappy. So we're going to move that down to the bottom. So 4 over 8 plus 2. Well, 4 over 8 is 1/2. So this is 2.5, which is reasonable. So 0, 2.5 would be about right there. All right, should we try? I think we should do 3 next because 3 minus 3 is 0. That will be an easy one. So let's do 3 next. So let's change the color. 4 times 2 to the 3 minus 3 plus 2. Well, 3 minus 3 is 0. So 2 to the first is 1. So that's just 4 right there. And 4 plus 2 is 6. So 3, 1, 2, 3, 4, 5, 6 right there. All right, and let's try, you want to do 4? Let's do 4 because that'll make that positive 1. I kind of like that. So 4 times 2 to the 4 minus 1 plus 2. Well, 4 minus 3 is 1. So 2 to the first is 2. 2 times 4 is 8 plus 2. So 4's partner is 10. Up there. And then I think I'll go over here on this side just so I have something getting closer. So I need some room. Let's go negative 2. Actually, let's do negative 1. Yeah, let's do negative 1. Okay, so 4, negative 1. So 4 times 2 to the negative 1 minus 3 plus 2. All right, negative 1 minus 3 is negative 4. And this part of this expression is unhappy. So we're going to move that to the bottom part of the fraction. So 4 over, let's see, 2 to the 4th is 16 plus 2. So that's 1/4 plus 2. So that's 2.25. So 2.25. So negative 1, 2.25. So it's about right here. And if you kept plotting points because of this plus 2 back here, the line or the exponential function with a curve would get closer and closer to 2, but it would never touch 2. Okay, because of this plus 2 on the back part of it. So if I draw the line, I don't want it to touch the 2. I just want it to get closer and closer forever without actually touching it. Okay, so again, the domain is all real numbers, and the range is y is greater than 2 because it's getting closer and closer to 2, but it's never touching 2. So it's not greater than equal to, it's just 2. Okay, so with the points, you can see that there's not like on a line we do 0, 1, and 2 because they're simple. But I have to think about what I want to use because it has to fit on the graph. You know, if I would have used 6, I would have had a very large number that wouldn't fit on the graph. So I can't use 6. And if I would have used negative 3, that would have given me a really, really small number, close, a little bit bigger than 2, but getting closer and closer to 2. So we had a 2.5, a 2.25. My guess would be 2.125, 2.16. Okay, so it would be getting closer and closer, but never getting to actually to 2. So, okay, so you're going to big ideas now to give these a try. You will have tables that you will need to write down so you can come up with points, and you will have some evaluates too that you will need to show work for as well. Okay, thanks very much. Make sure you submit that picture on Canvas.